Hey everyone, today I'll be doing the term 1 week 4 math quiz. So I'll start with question 1, which is very easy. It's just simplifying radical expressions. So we have this to simplify. Okay, so radical 4x y cubed plus 16x squared y squared all under radical. Okay, if you think about this, right, it's very easy. You can factor out 4y squared. So 4y squared, okay, you'll be left with xy plus 4y, or sorry, 4x squared, 4x squared. Okay, now take 4y squared out. Okay, you'll have that will go out as 2y, right, because it's going to be radical 4 times radical y squared when it goes outside. 2y into the radical of xy plus 4x squared. Done. Okay, next question. So, question 2. This is basically even easier, really. It's not that hard. They want us to subtract g of x from f of x, so this is basically going to be f of x minus g of x. This can be written as 2x cubed, so I'm just going to write what f of x is. 2x cubed minus 3x squared plus 2x, okay? Then I'm going to write the minus sign, open a bracket, because I'm subtracting g of x from all of f of x, all of g of x, right? So open the bracket, x squared minus x plus 2. So this here is f of x, right? And this here is g of x. Okay, now I'm gonna distribute the negative sign. So in one step, so it's gonna be negative x squared plus x minus 2. Remember, I just distributed the negative sign, so it's just gonna be opposite of everything. A negative becomes a positive when you have another negative sign, and a positive becomes a negative when you have a negative sign. So 2x cubed stays the same because we have nothing to simplify it with, minus 3x squared minus x squared minus 4x squared. Okay, and then plus 2x plus x becomes plus 3x, and then minus 2 has nothing to be simplified with, and this is our answer. Okay, moving on. Question 3. Okay, this is relatively new material compared to the other questions. So 2 minus x to the power of 7. Now, just as a quick refresher, I'm gonna want to write this in sigma notation. Before I do, let me again reintroduce sigma notation as a refresher. So if you have a plus b to the power of n, so this is gonna be the expansion of this in sigma notation is gonna be the sum from k equals to 0 till n, okay, then n ck and combination k into a to the power of n minus k multiplied by b to the power of k. Okay, just as a quick refresher, but I'm assuming you all already know this. Okay, so sum k equals to 0, 7 as the limits, n is 7, ck, a in our case is 2 to the power of 7 minus k, b to the power of k, b is negative x to the power of k. Now, we want at the coefficient of x squared, so k is going to be 2, right? So 7c2 multiplied by 2 to the power of 7 minus 2 is 5, negative x to the power of 2. This gives me, on a calculator, 7c2 times 2 to the power of 5 is 32. 672 into negative x squared. Right? Now, if you remember, whenever you have an even exponent, your negative sign will become a positive, right? You will, negative x squared will become positive x squared. Okay, so in a better phrasing, negative x all squared is going to be positive x squared, right? Because that's what an even exponent does. It flips the sign from negative to positive. So 672 x to the power of 2, and my answer is just going to be 672 because it's the coefficient that they're asking for. So moving on, I'm gonna leave this notation here because I need it for part B now. Part B, okay, it's gonna be instead of k equals to 2, we're gonna use k equals to 3. So 7c3, 2 to the power of 7 minus 3 into negative x to the power of 3. So 7c3 times 2 to the power of 4, because 7 minus 3, I'm gonna rewrite this as 4, right? 7c3 multiplied by 2 to the power 4, 2 to the power 4, 16. It's gonna be 560 into negative x cubed. Now, negative x cubed, all negative x all cubed, the sign in an odd exponent stays the same. Negative stays negative, positive stays positive, okay? Only in an even exponent where negative becomes positive and positive obviously stays positive. So here you're gonna have negative 560 x cubed, and 560 is my answer because they only want the coefficients. Okay, perfect. So I don't need any of these anymore. Sorry, I don't need any of these anymore. Now what I can do is answer part C. The coefficient of x cubed in the expansion of 3x plus 1, 2x minus 7 to the power 2x to the power of 7, sorry, is 1456. Now, instead of the expansion, right, since I only want the x cubed term, I can substitute these two into as this, right, since they're part of the expansion. And they both have the term that I want. They both contain the x cubed term. After I expand and multiply with 3x plus 1, you're gonna have the fully simplified x cubed term if you only put in both of these. So 3x plus 1 into 672x squared minus 560x cubed. Okay, now 3x plus 1 into whatever this is, we're just going to distribute 3x at the start. So 3 times 672, 2016. Okay, x to the power of 1 with x to the power of 2 becomes x cubed. And now we distribute minus 560 to the 3x. So minus 560 times 3, negative 1680. X to the power of 3 plus 1 is 4. Okay, and now since you have plus 1, you're just going to keep the numbers themselves. So plus 672 x squared minus 560 x cubed. Okay, now I'm only concerned with the coefficient of x cubed, right, as is given to me in the question. So I'm going to erase everything that has nothing to do with x cubed, right? The x to the power of 4 has nothing to do with x cubed. X to the power of 2 has nothing to do with x cubed. So all I really need is 2016 x cubed minus 560 x cubed, right? And this will give me 1456 x cubed, and this is my final answer. Of course, they only want the coefficient, so you write in 1456. Now, this is very easy. So, radical negative 2 times 3 minus x. Again, I'm just putting in a equals 3, so I'm going to put 3 where a is. So this equals 2, 3 into 3 minus 1. So it's going to equal 2 radical negative 6 minus x is going to equal 2. 3 times 3 is 9, 9 minus 1 is 8. Square both sides, negative 6 minus x is going to equal to 64. Take the x to one side and take the numbers to the other. X is going to equal to negative 64 minus 6 equal to negative 70. And this is my answer. Done. Question 5. If you can hear the national anthem playing in the background, I don't know why, it's a school next to me. So, consider the expression 1 minus 4x to the power of 1 over 2. This is the condition. I will explain this later. I'm going to explain this part in another question because it does come up, but not now. So we're not going to concern ourselves with it. Part A, I'm going to make this into a new note because it needs a new note. So, first of all, create note. Part A, they just want me to expand this, right? Yeah. So, part A is let me get a color that stands out more. Let me get red. A bit thicker. So, 1 minus 4x to the power of 1 over 2. Okay. Now, whenever you have a rational number as an exponent, remember a rational number is denoted by the set q. Okay. And a rational number is essentially any number that can be expressed in the form p over q. Okay, so as a fraction or a decimal, basically, right? So 1 minus 4x to the power of 1 over 2. The way you expand this is gonna be if the condition here, you have two conditions. Is this second part the absolute value of it? So negative 4x is gonna be less than 1. Okay, if and only if. This is how you write if and only if. And this is just going to essentially be 4x less than 1 in absolute value. So it's going to be 1 over 4, or sorry, I went too far ahead. So x is going to be the value of x is going to be less than 1 over 4, which is the condition we have in the question. As you saw, I told you I'll explain this later. I explain it now. So it's going to be the second term less than 1, an absolute value. So that's the first condition. The second condition is a in R expansion, obviously in the form a plus b to the power of n, right? A has to be 1. Okay, if it's not 1, you can factor it out, which I will do in another question because it is asked in another question. If it's not 1, you factor it out. But here it's 1, so we're not factoring anything out. Now, if you have both of these conditions fulfilled, you can use this formula. The sum from k equals 0 all the way till infinity. So it's going to be n in our case is 1 over 2, ck. It's going to be b, which in our case is negative 4x to the power of k. Okay, now, you have this, right, done. All you're going to need to do is now substitute. And then they want us to expand this as far as the term in 1 in x cubed. So we're going to start from 0, 1 over 2c0, negative 4x to the power of 0, plus 1 over 2c1, negative 4x to the power of 1, plus 1 over 2c2 into negative 4x squared, plus 1 over 2c3 into negative 4x to the power of 3. Okay, I'm going to stop here. So, really quickly, 1 over 2c0, any number, c0 is just going to be 1. Okay, so this is going to equal to 1. And any number raised to the power of 0 is just going to be 1. So this is just going to be 1 times 1, which is 1, plus 1 over 2c1. Any number c1 is just going to be the number itself. So it's going to be 1 over 2 multiplied by negative 4x. Again, any number raised to the power of 1 is just the number itself. Now, here, 1 over 2c2. How would I would explain this, but we're going to show you with examples. It's going to be much better, and then I'll show you the pattern. So, 1 over 2c2. We're going to write 2 factorial at the bottom. Okay, then 1 over 2, and then 1 over 2 minus 1. Okay, this is going to equal to, I think, negative 1 over 8. But let me just check. So, 1 over 2 minus 1, negative 1 over 8, yes. Okay, so it's just going to be plus negative 1 over 8 into 4x squared. It's going to be a positive 16x squared. Plus 1 over 2c3. This is going to be 3 factorial into 1 over 2, 1 over 2 minus 1, and 1 over 2 minus 2. Okay, this is going to equal to, I think, 1 over 16. Just let me just check. 0.5 minus 2. 1 over 16, yes. Okay, now, the pattern here. Let me explain how I got this and this. Because if you try this on a calculator, it's going to tell you math error. How do you do this? So, at the bottom, okay, at the bottom, you write the number that's here. Basically, in the other notation, that's here in the column notation, it's going to be 1 over 2c3. You write the number on the bottom as the denominator, factorial. Okay, 3 factorial. Now, you write the top number, which in our case is 1 over 2, as basically the factorial, but the number of factors is going to be determined by the denominator. So, 1 over 2 into 1 over 2 minus 1 into 1 over 2 minus 2, right? You have 1, 2, 3 factors, right? So, that's why we did this. Now, if you go up here, 1 over 2c2, so on column notation, it's 1 over 2 c2 is going to equal 1 over 2 c2, always seen. 2 factorial, and then we're going to write 2 factors of 1 over 2 factorial. So 1 over 2 and 1 over 2 minus 1. Those are 2 factors. So 1 and 2, as you can see. And then this gives us negative 1 over 8. So the general rule is n, c, r. R, by the way, this r here has to be a whole number. So it has to belong to the set of positive integers. Okay, keep this in mind. Ignore this though. This is, they're not going to give you nc 0.5. It's going to be r factorial, okay? And then the number of n factorial, but how many factors, it's going to be determined by r. So that's just the general rule. خلاص. Okay, so this is going to be 1 over 16 into negative 64 cubed, negative 64x cubed. I'm here, by the way. I'm here. Okay, this equals to 1 plus negative 2x, so this is going to be 1 minus 2x minus 2x squared minus 4x cubed. And this is part A done. Now, part B. Part B needs a little bit of focusing. It's not hard. They want us to substitute x to the power of 10, x equals 10 to the power of negative 2 to find the square root of 96. Okay, they want us to substitute x equals 10 to the power of negative 2 in this expansion to find an approximation for the square root of 96. Now, my goal here, okay, is actually not to start with this, because if I substitute this, I'll get 0.979797, something like that. Okay, I want to start with this, radical 96. Now, radical 96, okay, is equal to, if you think about it, 100 times 0.96. Okay, and you can take the 100 out. It's going to be 10 into radical 0.96. Now, our goal here, okay, is again to somehow get the approximation for radical 96 using this, which will give me, if you substitute it, right, it's going to give me 0.979797. But if you substitute this here, you're gonna get 9.79979797, right? Okay, so as you can see, it's 10 times this, and which is essentially what we got. So radical 0.96 or 0.96 to the power of 1 over 2. This is just to confirm that we have x is approximately equal to what is our 1 minus 4x to the power of 1 over 2. Okay, so now the 1 over 2 and the 1 over 2 are going to cancel, right? So 0.96 will be approximately equal to 1 minus 4x, because again, we're finding an approximation. 4x is going to equal to approximately 0.96 minus 1, or 1 minus 0.96, sorry. Give me 4x is approximately equal to 0.04, which is x is approximately 0.01, and again 0.01 is the same exact thing as 10 to the power of negative 2. So when we substitute 10 to the power of negative 2, what are we gonna get? We are gonna get the expression for radical 0.96, right? So what we're gonna find here by substituting x is equal to 10 to the power of negative 2, you're gonna find not radical 96, you're gonna find radical 0.96. Then we're gonna multiply it by 10 to get an approximation for radical 96. Okay, so what is our expansion? 1 minus 2x minus 2x squared minus 4x cubed. So substituting this into this, okay, it's gonna be 1 minus 2 into 0.01 minus 2 into 0.01 squared minus 4 into 0.01 cubed. This is gonna give me 1 minus 2 into 0.01 minus 2 into 0.01 squared minus 4 into 0.01 cubed. This is going to give me 0.979796. Okay, now this is an approximation for 0.96 under a radical. Okay, so approximately equal to 0.979796. Okay, however, as we showed before, okay, radical 96 is equal to 10 times radical 0.96. So radical 96 is gonna equal to 10 times radical 0.96. So it's gonna approximately be equal to 10 into 0.9796, which is gonna be 9.797997. So how much? 9797. So it's gonna be like this. 79796. So this is my final answer. 9.79796. Done. That's it. That's question 5. Okay, question 6. Expanding. Okay, this is very annoying. It's the same thing as the other question, so I'm also gonna do it too. So we want until x power 4. Perfect. So it's gonna be I'm gonna take the same note. 1 over radical, what was it? 9 plus x squared. Okay, so this is gonna equal to 9 plus x squared to the power of 1 over 2, negative 1 over 2 because we took it up. Okay, now this is going to be another expansion. However, this is where I told you about the other condition. Keep in mind, 9 has to be factored out because a has to equal 1, right? So, under the whole thing, it's going to be 9 into 1 plus x squared over 9. We're factoring out, remember? X squared over 9. All of this is going to be negative 1 over 2. Okay, now we can distribute this. We can distribute this here. So, 9 to the power of negative 1 over 2. Do it on a calculator. It's going to be 1 over 3, I'm pretty sure. So, 9 to the power of negative 1 over 2. It's going to be 1 over 3. It's going to be 1 over 3 times 1 plus x squared over 9 to the power of negative 1 over 2. Now, we can expand this. This part here can be very easily expanded. So, 1 plus x squared over 9 to the power of negative 1 over 2 is going to equal to the sum of k equals 0 until infinity, negative 1 over 2, k, and x squared over 9 to the power of k. Okay, we're going to expand only for the first two terms because this is going to give me x to the power 4. So, negative 1 over 2k, which is 0 in our case, start off from 0, x squared over 9 into k plus negative 1 over 2 c1 is gonna give me x squared over 9 1 plus 1 over 2 2 x squared over 9 squared. Okay, now why did I write this? Is going to be to the power of 0. Okay, see, this is going to all equal 1. Because remember, any number C0 is going to be 1. And then any number raised to the power of 0 is going to be 1. So it's going to be 1 plus... Okay, here. Now, any number C1 is going to be the number itself. So negative 1 over 2 multiplied by x squared over 9 plus 1 over 2 C2. We're going to do the method that I taught you. So 1 over 2 C2 is going to equal to 2 factorial over 1 over 2 into 1 over 2 minus 1. Remember, we're only writing 2 factors because we have 2 factorial at the bottom. So 2 factorial is just 2 into 1 over 2 multiplied by 1 over 2 minus 1, negative 1 over 8. Did I do this right? 1 second. I think I did. Yeah, I did. Okay, good. So plus 1 over 8. This is negative 1 over 2. So it's going to be negative 1 over 8. No worries. It's fine. Actually, no, it's going to be 3 over 8. So, no, this does make a difference. So, it's going to be 3 over 8 into x squared over 9, all squared. So, it's going to be 1 minus x squared over 18. Okay, plus 3x squared, or 3x to the power of 4 over 8 times 81. 648. Can this be simplified? 648 divided by 3. It can, yeah. So it's going to be 1 minus x squared over 18 plus x to the power of 4 over 216. I divided by 3 on both sides. Okay, now we're not done. This isn't the expansion because remember, we still have the 1 over 3 to multiply, right? So it's going to be, all of this is going to be multiplied by 1 over 3, which is going to equal to 1 over 3 minus, what's 18 times 3? X squared over 54 plus x to the power of 4 over 216 times 3, 648. So x to the power of 4 over 648. Let me just check if this is the right answer. 1 over 3 minus 1 over 54 x squared plus 1 over 648 x to the power of 4. Yeah, okay. This is perfect. Okay, now we got the first part A. Part A is done. Why I didn't do that? Part B, the values of x. This is the condition. Okay, recall that the condition has to be this is gonna be less than the absolute value of this is gonna be less than 1. So absolute value of x squared over 9 is gonna be less than 1. Okay. Now take 9 out of the absolute value, so it's gonna be x squared, an absolute value. It's gonna be less than 9. So you can take radical x, an absolute value all squared, less than 9, take the radical. X is absolute values of x is less than 3, so it's going to be negative 3 less than or equal less than x, which is less than 3. This is my condition. Part B is done. Part C, using the expansion as far as the x to the power of 4 term. So we're going to do the same thing we did for the other one, but they want us to find it with radical 1 over 10 because it was given in the question. So radical 1 over 10 is the same thing as 10 to the power of negative 1 over 2, right? Same exact thing. So what was our original expansion? 9 plus x squared to the power of negative 1 over 2. So 9 plus x squared to the power of negative 1 over 2 is equal to 10 to the power of negative 1 over 2. These two cancel out. So 9 plus x squared is equal to 10. X squared is going to equal to 9. 10 minus 9, which is 1. X is going to be positive or negative 1. You always take x is equal to positive 1. Okay, now what we're going to do is we are going to put this into our substitution, right? So since there is no we didn't simplify and then we do times 10 whatever, there is no gimmick like that. It's very simple because they only want this, right? Not like the other one where we had to find radical 0.96 and do that. No, you can't simplify that one. So here we're gonna substitute x equals 1 in our expansion, which is 1 over 3 minus x squared over 54, so 1 over 54, plus x to the power of 4 over 648, so plus 1 over 648 gives me 1 over 3 minus 1 over 54 plus 1 over 648, 0.316358. That should be enough. What do they want me to take it as? 4 decimal places. So 1, 2, 3, 4. So 0.3164. And this is my answer. Okay. An absolute value, the difference between the calculator value of radical 1 over 10 to 4 decimal places and the approximate value. Okay, so we're just going to find the difference between the two values. On your calculator, radical 1 over 10 is going to be radical 1 over 10 is equal to 0.3162. Okay, so 0.3164 minus 0.3162 is going to equal to 0.0002. That's it. This is my answer. Question 7. Hopefully a bit simpler, way simpler. Okay, good. So now you should already know this, but it's fine. First of all, summation rules. Okay, very important to know. First of all, you can distribute the summation to all of them. So this can be rewritten as the sum of k equals 1 to 20 of 2k squared minus the sum k equals 1, 20, 3k plus the sum k equals 1, 22. Okay, now the constant can be taken out. So it could be rewritten as the sum of, 2 multiplied by the sum of k equals 1 to 20 of k squared minus 3 into the sum of k equals 1 to 20 of k plus this can stay the same, so it can be, it's fine because it's a constant. Okay, now that I don't need this at the top here now. Okay, perfect. Now if you look, we have the rules given, so we're just going to substitute them into whatever we have here. Okay, so the rule for k squared is going to be 2 multiplied by so over 6. Obviously I always start with my denominator. It's going to be from k equals 1 to n. So oh my god, not this. It's fine. So it was 2 multiplied by n in our case was 20 because n is at the upper bound of the summation. So the upper bound of our summation was 20. So it's 20 into 20 plus 1 into 2 times 20 plus 1 over 6 minus 3 times 2 into 20 plus 1 plus the rule for a constant is if it's k equals 1 till any number n and it's a constant a, let's say, it's gonna be a times n. So here we can apply this. 2 is our constant. Our upper bound is 20, right? So it's gonna be 2 times 20, which is 40. Okay. So this is gonna equal to what's all of this on a calculator? This big fraction over 6. 20 into 21 into 41 to 870. So it's 2 into 2, 870 plus 3 into, or sorry, 20 into 20 plus 1, 20 into 21 divided by 2, 210. So 3 into 210 plus 40. Do this, simplify it now. So 2 times 2, 870 plus, or sorry, minus 3 into 210 plus 40, 5150. Done. This is your answer. Now, the only reason I'm skimming through this question, I'm not explaining it really well. I have explained it in detail in the, I believe, the second CA quiz or the first CA quiz I did, I'm not sure. I did explain it in detail. However, this has come up 4 times now, and not only that, everyone I know at least is doing it on a calculator, because your calculator can do this for you. This is why I'm skimming through it, but obviously I did explain it, and I have explained it before, so this explanation was just as a quick refresher. Okay, question 8. What's the coefficient? This is another example of binomial expansion, but it's very easy. So x5 term, meaning that here k is going to be equal to 5. So 7c5, I'm not going to write the summation notation for this. 2x to the power of 7 minus 5, or sorry, k is equal to 2. K is equal to 2, because 7 minus 2 is going to give me 5 into minus 1 over 4 all squared. This gives me 7c2 times 32 times 1 over 16, 42. X to the power of 5, plus we only want the coefficient, so we're only writing 42. The third term. Okay, whenever they tell you the third term, that means k is going to equal to 2. Okay, as a general rule, the nth term, okay, then k in our expansion is going to be n minus 1. This is a rule. Memorize it. So here they want the third term. That means k is going to equal to 2. Right? So 5c2, 1 into 5 minus 2 is 3, 4x to the power of 2. This gives me 5c2 times 1 times 16, 160 x squared. That's my answer. I'm skimming through these because you know how to do them. And I'm not writing the summation notation, but you can always write it and then expand based upon that. But the summation notation, you should have learned how to expand without it by now. And you really should if you haven't, because obviously in written parts you have to show the summation notation, the sigma notation. But in a computer part where you have a lot of questions, you will not have time to write summation every single time. So you have to work fast. Here, okay, the coefficient of 1 over x to the power of 4 term. This can be rewritten as x to the power of negative 4, right? Same thing. Now, a little trick you can use. So, ignore whatever's up here and ignore whatever's next to this. X to the power of, in this case, in our case, it's 12 minus k, okay, times 1 over x equals to x to the power of negative 4, okay? Ignore what, if you have, for example, 4x minus 1 over 8x, okay? Ignore whatever is here and ignore whatever is here and here. Let's say this is raised to the power of 8. So, let's say you want to find, I'm going to explain this using this example that I just gave you because it's a bit harder. Let's say you want to find the 1 over x to the power of 5 term. Okay, so you want to find 1 over x to the power of 5. This can be rewritten as x to the power of negative 5. Right? So, Now, what you're gonna do is you're gonna distribute this, right? You're gonna apply the binomial expansion, but in a shortcut method. So x to the power of, again, I'm ignoring my coefficient, x to the power of 8 minus k multiplied by 1 over x to the power of k is gonna equal to x to the power of negative 5. Okay, I can take this up. So it's gonna be x to the power of 8 minus k times x to the power of negative k. It's going to equal x to the power of negative 5. You have the same basis, so you can write 8 minus 2k equals negative 5. So 2k here. Okay, this term doesn't exist. This is because this binomial expansion, I just came up with it. So let's make it, you want to find the 1 over x to the power of 6 term. I'm pretty sure this will exist. So now, take 2k to one side and take the numbers to the other side. 2k is gonna be 8 plus 6, which is 14. Is it? Yes. K is equal to 7. Okay, and now when you substitute k is equal to 7, so it's gonna be 7 in this term, and then you'll find your coefficient. Okay, that was just a bunch of yap for no reason. I will show you how to do it properly with this. So this is a much simpler example. Okay, so x minus 1 over x to the power of 12, right? The summation notation for this one, sigma notation, is k equals 0 over 12, or sorry, 2 over 12, 12 ck, x to the power of 12 minus k, and negative 1 over x to the power of k. Now, this is where I get my 12 minus k and k in my shortcut, right? This is where I find it. From this and this. Okay, so x to the power of 12 minus k multiplied by 1 over x to the power of k. I'm distributing. Okay, 1 over x to the power of k. Again, if we had a coefficient in the expansion, you ignore it. Okay, you only put the x's, and if you have a fraction, you put 1 at the top. If x is at the bottom, of course. If x is at the bottom, you only put 1 at the top. That's it, nothing else. Okay, this is gonna give me 1 over x to the power of 4. Now, let me erase this part here. So 12 minus k, or yeah, this can be rewritten as x to the power of 12 minus k multiplied by x to the power of negative k. It's gonna equal x to the power of negative 4. Okay, so now, you can, since you have the same base, you can only use the exponent. So 12 minus k is equal to minus 4. So 12 minus 2k, sorry, ignore that voice crack. 12 minus 2k is going to be negative 4. Take k to one side and take the numbers to the other. 2k is going to equal to 16. So k will equal to 4. Done. Now, what was the point of this? Or sorry, k is equal to 8, not 4. Now, you can substitute k in our original expansion. So, if you remember, our summation notation was the sum from k equals 0 to 12 into 12 ck into x to the power of 12 minus k minus 1 over x to the power of k. Okay, k in our case was, as we said, 8, so 12c8. X to the power of 12 minus 8 is 4 into negative 1 over x to the power of 8. Again, here now you consider the coefficients, but whenever you're finding k, you don't consider them. Okay, so 12c8 times x to the power of 4 is just 1 times negative 1 to the power of 8, which is again just going to be 1, right? So it's going to be 495 over x to the power of 4. That's it. That's our answer. Question 11. What's the constant term? This is another thing this is another case of the shortcut you can use. So, another application of this shortcut. It's also a nice one. So, to find k, let's find k really quickly. X to the power of 12 minus k times, we're ignoring the coefficients, okay? Even the sign, we're gonna ignore it. If here it's negative, we're not gonna put the negative sign. 1 over x to the power of k equals to, a constant term means you don't have x, right? You have no x. So x to the power of 0, because remember, any number to the power of 0 is going to be 1. So it's going to equal to x to the power of 0. So it's going to be 12 minus k, or sorry, x to the power of 12 minus k times x to the power of negative k is equal to x to the power of 0. Right? Now you can work with only the exponents since you have the same base. So 12 minus 2k is equal to 0. 2k is equal to 12. K is equal to 6. Okay, so now you use this in the expansion. So it's going to be 12c6 into 2x to the power of 12 minus 6 is going to be 6 into minus 1 over 2x to the power of 6. This is going to equal to 12c6 times 2 to the power of 6 is 64 times negative 1 over 2 to the power of 6. It's going to be 924. Again, no x because it's just a constant. So 924 is our answer, question 12. This is another application of the binomial theorem. So x plus 4 into 1 minus x to the power of negative 2. Because look, it's 1 minus x squared at the bottom, but you're going to bring it up. So when you do that, this is what you're going to have. Okay. First, we're going to expand this alone, right? We're going to expand 1 minus x to the power of negative 2. So 1 minus x to the power of negative 2. We're going to use the formula we used before, which is the summation from k equals 0 to infinity. Negative 2 k into negative x to the power of k. Okay, so we're only going to expand until the x cubed term. So negative 2c0 into negative x to the power of 0 plus, or wait, actually, we only have to expand till 2, till k equals 2. Because if you think about it, right? Or no, wait, we do have to expand until, never mind, ignore what I said. So negative 2c1 into negative x to the power of 1. I'm not going to write the power of 1. Negative 2c2 negative x squared plus, I'll write it here, negative 2c3 negative x all cubed. Okay. Now, this is going to be 1. This is going to be 1. So 1 minus, or sorry, plus 2x, because any number c1 is going to be the number itself, so it's minus 2. Minus 2 minus x, minus 2 multiplied by minus x is going to be plus 2x. So now, minus 2c2, again, you can't do this on a calculator, so minus 2c2 is going to equal 2. 2 factorial, or 2 minus 2 minus 2 minus 1. This is going to equal 2. So 2 factorial, minus 2 minus 2 minus 1. 3. So 3 into x squared, negative x squared. So a negative x squared becomes positive x squared. So it's going to be 3x squared plus, or maybe probably minus. So minus 2c3. We're going to add another term here, minus 2, minus 2. So on a calculator, keep going from where you had your minus 2c2. Minus 2 gives me a minus 12. So minus 12x cubed. Okay. We have this. Now, oh wait, this is going to be, I almost made the same mistake I did earlier. So no, this is going to be not the answer, because 3 factorial, this is not the same answer. So I used the 2 factorial in the one I just did now. 3 factorial 6, so minus 2 into minus 2 minus 1 into minus 2 minus 2 gives me minus 4. So minus 4 into minus x cubed, so plus 4x cubed. Okay. That's done now. However, we're not done with the whole thing, because we still have to expand the very, very nice 1 plus, or sorry, x plus 4. So all of this with x plus 4. Okay, so x plus 2x squared plus 3x cubed minus 12x to the power of 4 plus 4x to the power of 5. Okay, or wait, what? I skipped something. 1 second. X squared, 2x squared, 3x cubed. 4. Wait, what? 1 second. Okay, so the correct expansion, this is where I just made the calculation here. The correct expansion is x plus 4 into 1 plus 2x plus 3x squared plus 4x cubed. Okay, and then it keeps on going. So now we're gonna distribute to x plus 2x squared plus 3x cubed. The x cubed plus 4x to the power of 4. Okay, now the time for the 4. So it's gonna be 4 plus 8x plus 12x squared plus 16x cubed. Okay, I'm gonna erase all of this at the top. I don't need this for x to the power of 4. Okay, so the constant term, it's gonna be 4 because we have nothing else to match it with. That's it. Now, x plus 8x, 9x. Okay, so x and 8x, 9x, done. 2x squared, 12x squared, 14x squared, done. 3x squared, 3x cubed, and 16x cubed, 19x cubed. That's done. Okay, question 13. This is derivatives. Finally, something fun. Okay. Here what I would do, you can apply quotient rule, you can also apply product rule if you take it up. But what I will do is, since we haven't learned those rules yet, although I did teach them in a video or two, I think last year, but you all probably forgot, so I'm not going to reintroduce them until we have them introduced to us and by the school. So 5x times, this is going to be just as a simplification, x to the power of negative 1 over 6. Okay, so this is actually going to be 5x to the power of 1 over 2. Okay, so y is going to equal, very easily, radical 5 times, here I'm going to keep x as x to the power of 1 over 2. Okay, why? Because I also have x to the power of negative 1 over 6. These two are the same base. I can add them up when I have multiplication. Remember, it's x to the power of a into x to the power of b. It's equals to x to the power of a plus b, right? So here it's gonna be y is equal to radical 5 times x to the power of 1 over 2 plus negative 1 over 6, yani 1 over 6 minus 1 over 6 essentially. 1 over 2 minus 1 over 6 is gonna be 1 over 2 minus 1 over 6, x to the power of 1 over 3. So times x to the power of 1 over 3. So this is going to give me y is equal to pretty much it. So it's going to give me radical 5 over, or sorry, wait. Yeah, so wait, this is my final equation. Okay, but now I'm going to derive. So dy by dx, or y prime. So y prime is radical 5 times 1 over 3x. What's 1 over 3 minus 1? Negative 2 over 3. Exactly. So remember the rule for the derivative. Okay, the rule for the derivative. If y is equal to ax to the power of n, then y prime, or dy by dx, is going to be a times n x to the power of n minus 1. Okay, this is essentially what I applied here. So you take the power down and then you subtract 1 from the power. That's essentially what the rule of the derivative is. So that's what I did. I took the power down, 1 over 3. Okay, then I subtracted 1 from the power. So 1 over 3 minus 1 is negative 2 over 3. Okay, if you just want to memorize it like that. Take the power down, multiply, and subtract 1 from the new power. It's going to be radical 5 over 3 into radical cube root, because remember the number at the bottom, when it's an exponent, is the denominator, is the index of the radical, into x squared, and this is my final answer. Okay, this is easy. So you have the sum, you have whatever it gives you, ci, and then they're just asking you to multiply it by 10. So 20, and then 20 times 10 is 200. There's nothing to explain here. Okay, this is an application of the rule I told you before. When you have a constant, let's say k, and you have I equals 1 to 100, it's just gonna be or n, sorry, it's gonna be nk. Okay, so like how here we have the sum of 2 from I equals 1 to 100. It's gonna give you 2 times 100 and give me 200. That's my answer. So I'm writing really quickly because I have to go do something and it's been an hour. So here, same exact thing. So you do this on a calculator. It's gonna give you, or let's do it physically. So 1 into 2 times 1 plus 1 plus 2 into 2 times 2 plus 1 into 3 into 2 times 3 plus 1 into 4 into 2 times 4 plus 1. Obviously you should do this on a calculator because they might ban integral calculators, and non-integral one don't have summations. So plus 2 into 2 times 2 plus 1 plus 3 into 2 times 3 plus 1 plus 4 into 2 times 4 plus 1, close the bracket, equals to 70. That's your final answer. Question 17. You distribute the summation to all of them, and then you will find that they gave you what the summations are essentially. So it's going to be 25 plus 30 minus 10, which mentally you can do 55 minus 10, 45. Question 18. Okay, so y is equal to 6x to the power 16. So what did I say the rule was? Take it down, 16x, subtract 1 from the power, 15. That's your final answer. Okay, y is x to the power of 7 over 4. Okay, because I changed this into the fraction form, so into exponential. So 7 over 4, this is obviously going to equal to 4th root, because remember the denominator is the index of the root, and the first one's how much it's raised by. So it's like this. Okay, now dy by dx, or y prime, is going to be 7 over 4 x, 7 over 4 minus 1 is 7 over 4 minus 1, 3 over 4. Okay, so now dy by dx at x equals 16, you're just going to substitute 16. So 7 over 4 times 16 is the power of 3 over 4. Do this on a calculator. 7 over 4 times 16 to the power of 3 over 4, 14. That's my answer. Question 20. Very easy. So y is equal to 10x to the power of 25. Take it down. So y prime is going to be, you take this down, 25 times 10. X to the power of, subtract 1 from the power, 24. Y prime is going to be 250x to the power of 24. 21, which is the last question. What is the derivative of y equals negative 12? Whenever you have a constant, okay, y equals k, no x, no nothing, then y prime is going to be 0. That's the rule here. And this is the end of this quiz. Good luck, guys. Have a good day.